Hello, welcome to episode 16 of this series on making a game for the NES. The last episode, which was a little bit off from usual, we were doing some cleanup work and working with the sprite bounding boxes and changing that up a little bit since we're not supporting anything other than just simple rectangular bounding boxes, and had shown how we could manipulate that by editing the sprite file directly. So we had done that by just simply opening the file in this hex editor and going in and looking at the information that controls the size of the bounding box. So if I modify that size and I reopen it, you can see it shrunk the bounding box. So I'd like to change that so that that's something that we can edit in the tool, obviously, but I'm thinking we've spent a lot of time working on this. I'd like to actually get something into the game directly. I feel like we spent a lot of time just messing around with this and haven't gone back into the NES side of things. So I created this new ship. I want to include that in the game. I want to use the tool to generate the assets for it, and then we can go into the game and load the material that's generated by the tool, both to get more into the NES side of things and also to get kind of get that structure working the way that we want to. So I want to create the sprite for that. So we've got our ship, and we talked about last time that the colors are slightly different because the palette that we're using when we create the file in Photoshop is a different set of colors than the colors that we're using in the tool here, where it's defined up at the top here. And I probably need to do some export, do an export of these colors so that they match, just because I'd like to be able to see specifically, what the colors are going to look like, in when we're drawing these things rather than after we import them already. It's kind of better to have it be a one-to-one. But anyway, so we've got our two sprites, and basically the idea is here that without any of the other stuff that we might need, when we hit the export project button, I'd like for it to export the content of the sprite files that are here in this folder into a single file that includes the character, the char-rom data, and information about how to compose these sprites. Now, obviously, the one thing that this doesn't have the title screen in it, so there's going to be a little bit of maybe messing around we might need to do to make this work properly, because it doesn't have all the assets loaded into it. Eventually, we should probably take the title screen. I don't know if I have the title screen here on this computer. I might have it on a different machine. Eventually, we should get that that file loaded into here and start making the asset tool be able to not only create a sprite on a PNG, but also create backgrounds and then use that for maps and stuff like that. So that's okay. For now, let's talk about how we're going to export this stuff. So in the main asset tool, the first thing we're going to need to do is look at what files we want to actually export when we export the project, right? So we want to loop through the current item count and look for files that are sprite files to start out with. So now, I thought I remembered creating some sort of helper function to check extensions. I created something called isSprite, and then I remember I created a helper isMatching extension. Okay. So let's go back down here. IsMatching, well, I'll just say isSprite. Current file list oops. Oh, I just need the name. Okay. So if that is the case, so let's look at how the game is currently handling sprites. From the perspective of drawing the sprites, it is hard coding the tiles that are used for the sprites and then loading them into the appropriate number of sprites that are needed for the sprite that we're, or for the thing that we're drawing, right? So if you recall when we were talking about this, the NES, the sprites are either 8x8 or 8x16, so the player ship, for example, is actually 4 sprites because the player ship, we can look at that here, is 16 by 16, and that's a special case where it's actually mirrored, where we have just these 2 tiles next to one another, and then we're flipping them horizontally in order to be more efficient about the way that we're storing the tiles. We're not storing duplicates. Now, this blaster ship that I created, it's also symmetrical. But I'm not going to tackle that yet. I want to get the information exported and usable, and then we will worry about how we're going to optimize those tiles afterwards. So let's see. So how would we do that? So right now, we're iterating through our entities, and we're looking at the type of the entity, and based on the type of the entity, we're drawing appropriate sprites. So I wonder if the first thing we need to do, maybe we will export the player, because originally I wasn't going to do the export of the player ship, but now that I'm thinking about the way that this works, I kind of want this to be the same for everything, right? So the player ship is special in the sense that it's it's controlled by the player, but the way that the data is handled shouldn't necessarily be any different from any of the other entities. So I'm going to create a sprite, turn that into a sprite. So we've got our sprite version of this now, and then basically what I'm wondering is if we should, right now the entity type that is being used is a hand-coded thing here in this array of entity types. I'm wondering if that's something we should actually import from the asset tool. Like, for example, it will use the names from here and generate the entity type definitions based on the content of the project. I don't think there's a problem with that, in that it would, the names would be consistent as long as we don't change the names here. I guess it's not really a problem so much as it's going to change this functionality a little bit, because yeah, I think that's probably okay. I mean, we'll see. If that doesn't pan out the way we want. So what I really want to do is I want to change this, instead of defining this here, we're going to change this to be an include, right? And then we're going to generate the entity's scope, the entity type scope. So if it's a sprite, let's see, there are a few files we're going to need here. I guess we're going to iterate through this a few times, because the first thing we need to do is generate the entity list with the proper entity enumerations that we're going to include. And then the entity behavior is not going to change because the entity behavior isn't going to change because that has to be coded in, at least for now. We could export that out and make that something that we have in the project where we define the behavior separately, and then include that in our processing of the behaviors here, or well, not here. Where is that? Yeah, and here, where we're actually processing how quickly it moves down the screen. But I think for now we'll make that be something that's hard coded. So we're not going to have the bullet. I mean, the bullet is just this tiny. Well, that's okay. I don't want to get too far ahead of myself here. We can always manually add bullet in, even though we don't have the type as a sprite in the project, which eventually it will be. But all right, let me just do this. I'm going to sit here trying to figure out what it is, but let's actually just do this and see what this looks like. So the first thing we want to do is we want to enumerate through our entity types. So this is going to just be text, so we can just even do this as just doing fopen. We're going to do write, and then if it's not null, let's go in and we're going to create our entities file. So here's our little message, automatically generated entities file from NES asset tool, right? Oh, I gotta actually. And then for each of these, so we do printf entities. What is it? Dot scope entities. Oh no, entity type. Entity type. Again, a new line. And then we want to do our no end. So this actually is one. No entity is the default type. I just want to make sure I'm getting the syntax right as I'm doing this. And then I guess we should. I want to keep this consistent so that it doesn't require me making changes to the assembly code. So I'm just going to rename these to match accordingly. What's neat is you can see that the asset tool is picking up on those changes automatically, so we don't even have to restart or refresh or anything. And this is actually, I think it's technically player. Okay. So that's good. All right, so let's generate a entity based on the current entity we're looking at. So get file name with a temp, and then current file list name. So that's temp, and then entity count plus, because we need to increment that. Got to define get file name. Let's see. Get file extension. And it's basically sort of the same thing, just the reverse part of it we're going to get. So just got to give it a max here. Okay, so we want to go backwards and find the period, and then from there we're going to copy into the buffer, name buffer. We're going to copy from 0. Is there a substring? No. Really? I thought there. Is it string? That finds a string within the string. Well, this is actually easy enough to do. So what we can do is we can set this to be null character, and then yeah, it doesn't like that we're doing this because I said it's a const. Fine. Technically, we shouldn't be messing with that. Not that it really is going to make a difference, because we know we're doing it in a way that shouldn't be a problem, but whatever. It's not the right thing to do. So okay, we put it into temp, and then we're using temp, and we're going to modify that. So basically, we're just setting the period to null, so we can grab the substring that we want, which is just the file name, and then we're done. Return. We can do the same thing here. What's the matter? Oh, yeah, gotta give it the file name. And then we should be also doing an fclose. And a comma helps. Maybe unsafe. I don't know how. Okay. Give the pointer to that. Okay, so we got that. I missed the semicolon. Oh, I put a colon. Okay. All right, we've got the tool open, so let's close that. All right, so if I click on export project, it should now generate that include file that we wanted to. So we can open that in Sublime Text, maybe. Okay, so that's pretty good. It's got the extra lines there, and we're missing end scope. So let's fix that. Definitely need the end scope. Oops. Let's just do, it's because of the carriage return and the new line. We don't need both. or fprintf. Misspelled it. Okay. So let's run that. And export. And Sublime text. There we go. So that's defining our entities type. No entity blaster flyby player. Now, in theory, that shouldn't actually break anything by changing the order, because I was using the entity types everywhere. But let's give that a try, because I'd rather find out now that that's broken than find out after we've gone through this whole process of making a whole bunch of other changes. So let's build that. And oh, did I misspelled end scope. Yep, end scope. Okay, so export project. And put that into here. And then the other thing we probably want to do is we probably also want to modify our make file to look for these include files, so that when they change we get a new build created. So let's see. Title screen.inc. What else? Shooter char. Alright. No rule to make shooter. Well, it shouldn't be trying to make it. It should just be. Oh, is it because it knows that it's some sort of code? Actually, don't want it to do anything for these guys, but alright. Alright, make. Hopefully this will satisfy you. Yeah, okay, cool. Alright, so the only thing that I'm missing right now is bullet, because we don't have the bullet. Let's just fake that for now. Symbol bullet undefined. Entity type bullet. Am I modifying? Oh, maybe I'm modifying the wrong one. Shooter. Oh, that's in the, okay, that's in the asset tools folder. That's why. Let's move that over. Okay. So build. So that's built. Let's see if this is broken. So far, so good. The ship looks good. That's all still working the same way it was before. Just missing. Alright, so that's cool. That was what I expected to have happen. Okay, good. So let's pause. Let's shut this down. Okay, so now our entities are being generated by the tool. We'll get the bullet type, obviously, when we get to the point where we actually have that image that we can load up in the project. So that's that. All right. So the next part of this would be the collision information, and so a few different things here. This is actually going to be a pretty big change in terms of the way collision is done. Like this part, we can't really change the way that this works, because the way that this works, you know, like I said before, the code to handle the actual entities themselves, unless we put something into the tool that generated assembly code that we could include in here. It would need to, without that, it would need to, or if we took this out, it would need to do that in the asset tool. But I don't know that I really want to go that route, especially not right now, given that we're trying to kind of move along with the game. So what I'm thinking is I want to move on and do the entity drawing stuff here, where basically we're dealing with how we're handling the drawing of sprites. Now the bullet entity will cheat because basically we haven't gotten there yet. But looking at this, I'm actually thinking that the tool is going to have to generate the code to update the memory, because so what's going to have to happen here is, so right now we're hard coding all of our processing of the memory for the entities, for the sprites. In here we're looping through all of the entities, and we're saying, okay, if it's this type, then call this, and then this is going to populate the different entities in memory that ultimately map to sprites in the hardware. But what I'd like to be able to do is, based on the fact that we're externalizing these entities in this tool here, is say, okay, well, so we know that this is a 16 by 8, which means that it's actually 2 sprites based on the current size. So let's generate assembly code that will update the memory to handle the drawing of the sprite. Now, this is going to be a little tricky. I mean, it can't just do it sort of in the void. I think it's going to have to work, knowing something about the way that the engine, I don't think it does. It's definitely going to have to work knowing something about the way that the engine is processing things, because otherwise I don't know how it would actually do this without it requiring hand-coded population of the memory. Like I said, with the player, it's a little bit different because we're loading the sprite from the tiles and doing flipping and stuff like that. We're gonna stop. We're not going to do that right now. What we're going to do is just kind of go with the most basic case, and then we can do the optimization of the tiles. So let's start with the flyby, since that's the easiest. So the way that this would work is this loop, this whole loop essentially of populating the memory is going to have to happen in another file, right? So we're gonna do something like include draw entities.inc, and this is going to be assembly code that gets generated by the tool to populate the sprite memory for the game. So, well, let's start from the beginning here, right? It's just going to be a matter of kind of powering through this. So we've got the entity types exporting properly. Once we've got that working well, which we seem to be, the next thing would be to, I'm going to put this into its own, all into its own scope, because we don't need any of the stuff that's in here once we're done processing. Once we're done processing this, although, we could probably update all the files all at once, just so we're not looping through this list over and over again. let's do that. It's going to be a little bit messier to understand how that works, but it should be relatively straightforward. So the next file we're going to open is what did I call it? Draw entities. Drawing. So again, this is going to be essentially assembly code that we have sort of a boilerplate for, and we auto-generate based on the image data. And, you know, knowing what the char ROM is going to look like for the image that we've already converted into a sprite. So so if the entities are good and the drawing is good, so start boilerplate for entity, include start boilerplate for entities drawing. Let's see. So coming into this, we're using this variable sprite mem to index into the location in memory for our OAM data, right? And if you remember way back when we first started looking at this, this is because unlike other systems that have sprite hardware where the information is persistent, on the NES, once the information is written and the screen is refreshed, it basically just, for all intents and purposes, it disappears. It's more complex than that. The data actually decays in memory, so it loses its consistency, and so it's no longer valid, which is why that you have to mirror that sprite memory in your RAM. So we're storing that at 0200 hex in memory, and the first thing I guess we really need to do is we need to start by replicating this. So I don't know that I needed to really copy that into here. We can pull it out of we can pull it out of it one line at a time, right? So that's our label for the loop. Probably want to put this into its own scope just so the labels don't conflict with anything. So let's do that. So call this scope entity drawing new line. All right. So we've got our label. And let's see, what are we doing? We're looping through this entity's memory. So again, there are going to be assumptions that are made by this code to determine how to do all of this, right? So the first thing it's going to assume is it's going to assume that we have some memory that we've defined called entities that it can then look into this entity type member of the structure. And it's also assuming it's going to assume that we're indexing using the X variable, or sorry, register. We may want to change this and push that onto the stack so that it can be called independently. But for now, I'm okay. I'm comfortable with it doing what it's doing here. So again, we're going to have this assumption here. Tab that. So we've got, we're going to do our load. And now here for the comparisons, I mean, this is pretty straightforward, right? For the comparisons, all we're going to do is now iterate through the entities that we have. And we can do that by looping through this list and comparing. All right, so it's kind of an interesting. I don't know that I envisioned it working this way, but it's kind of an interesting way to do it, and it just makes it data driven. You know, from your project that you're building in the NES Asset Tool, rather than well, it's not data driven 100%. Like, it's data driven based on the data that you're using in the asset tool, but then the asset tool is generating code rather than generating metadata about how to load the sprite. Like, we could do something where we say, you know, this sprite is actually this many tiles by this many tiles, and you know, it consists of these tiles, and it, you know, has this many sprites and whatnot. And you know, the NES could probably do that. I don't know that that's really super. I mean, it's not really as efficient as just essentially writing code to do that for you directly, because you're eliminating, by doing that, you're eliminating all of the extra comparisons and checks and constraints that we could do really easily on the asset tool side, where the processing power is a lot more available than the NES, running at its, you know, whopping 1.7 megahertz. So let's do that here. You know, I think that's going to be a good approach to this. So output entity enumeration value, and then output drawing comparison condition. So again, this is going to be a little bit goofy because it's intermixing the two processes, and one of defining the entity types in the scope, and the other is this code that it's actually generating for the NES. But I think it's, I don't know, maybe it's not. Maybe we're better off splitting it up just so that it's easier to understand. I'm going to do that. It's less efficient to keep looping through the stupid list, but at the same point, it's going to just create lots of confusion later on when we're trying to add more and more complex things. And then, you know, we get stuck in this situation where it's like everything is all intermixed. And then this way we can also easily just factor these out into functions that we can call separately, whereas if they're intermixed, it's going to be harder to do that. So while I like the idea initially, I think I prefer just keeping it as simple as possible and as straightforward as possible. So this is all going to be the same because we still need to just get the name of the thing. Oops. Okay, right, so we've got that. So if it's drawing, and then we want to remember to close the file here. Let me just move this down to here. And then, like I was saying before, and that. Okay, so we have the drawing, we have the file, we're outputting our scope, we have our label, we were loading the entity type based on X, indexing, and then we are doing our comparison. So this goes down to here, right? So we say, okay, compare with entity type, nope, entity type, and then the name is going to be that. And then we have a new line where we're going to do branch if equal, and we'll just call it like draw, and then the thing, and then sprite, right? That way it's kind of consistent. And then of course we have to do our end scope, right? So that should draw at least the initial comparison, not draw the initial comparison, do the initial comparison checking, and then we have the boilerplate of we have to check the end. You know, we have to have an end condition, right? So if we, where is it? In this loop, if we hit a type that we don't recognize for some reason, we then have this check end sprite that we're going to call. So we need that, you know, if this were a switch statement, this would be the default case, right? So that's just jump check end sprite, new line. All right, so that's that, and then we actually have to define that label. And then, okay, so obviously there's some drawing code that's going to have to go here. And then once that's done, we have our label check end sprite. Right, so that's that. And then we want to check. So we want to increment x and then check to see if we've hit the total number of sprites. And again, this is going to be, you know, this is all sort of predetermined based on information that the tool is designed to assume about the way that the underlying code in the assembly works. And that's fine because, you know, we're essentially this shooter project is going to get, we're going to strip out more and more of the things that are specific to it once we're done with it, and make it actually more generic, where we can build other projects using the bones of the project. So, you know, and that's not going to be applicable for everything, but we'll do our best to kind of make it reasonably reusable. So same thing here. We're going to transfer x to a. Just add in a bunch of new lines here. So that's CLC now. And I feel like we'll probably end up making this code external to the asset tool so that it's not hard coded in. But for now, it's okay. You can always go back and fix it. So we're just kind of replicating all this code that we've already written to get where we are right now. And then done sprite, the last label, and then we end our scope. And we're good for that part of the game. So what I'm gonna do is I'm not gonna delete this. I'm gonna pull this out into a separate buffer for Sublime Text because there's gonna be stuff that we need to do to make this work. So that's in there, and then we have that. Okay, so making me a little nervous here to do this way, but you know it's okay. So let's try that. So if we export the project, we should get a few different files now. So we have draw entities inc. Let's take a look at what that looks like in Sublime Text. So there's our scope. There's the label to draw the entities. I forgot a new line. There's the blaster, flyby, player, and then the jump to check and sprite, because that's our default case if we don't recognize the type for some reason. That's all pretty good. Obviously we don't have those labels anywhere. We'll have to define them. So let's fix let's fix the new line that's missing. Where is that? Here. And then sort of in the most lazy fashion possible, we're going to add our drawing labels here. Just again, just to get this going. We can come back. This is just a tool, you know, it's not going to kill it if it's not the most efficient thing in the world. Obviously it'd be nice for it to be more efficient than what we're doing here, but let's get this importing into the game, and then we'll worry about the efficiencies of our asset tool. All right, so if we reload that, cool. So those are the labels. If we look at the way that this works, it's pretty much the same thing, right? We're comparing against the type, and if it's equal, we're going to jump to this label now. And then now we got to add that code that actually does what this is doing for the flyby, for example, where it will set the X and Y coordinate and do that for every sprite, every 8x8 sprite. The palette information is something that we haven't dealt with at all yet. So that's going to be interesting also, because we're going to have to manage, we have to think about how we're going to manage the sprites, what sprite is currently loaded. Sorry, not what sprite is currently loaded, what palette is currently loaded. If we're going to do dynamic palettes, then that palette index is going to be potentially different. We'll have to think about how that's going to work. I'll have to think about that, but again, it's not here or there yet. All right, so we have our label. The only thing, the only thing that's kind of boilerplate, well, a lot of it is boilerplate, but the important things are going to be the tile numbers and the palette numbers. The rest of the stuff, the X position, Y position, that's all fixed. The sprite mem, the increment of the Y. Keeping in mind, so like the flyby is a single sprite entity because it's only 8x8. So when it's incrementing this Y value, it's just incrementing through our memory for the sprite, right? Because the sprite OAM data consists of these 4 bytes. So you've got your, what is it? So you've got your Y, you've got your tile, you've got your palette, and you've got your X. Is that right? There's some more to it than that, and we can look at that here. But those are generally those are the important ones, besides the flipping of the sprite. So let's take a look at this here. So byte 0, okay, byte 0 is Y, byte 1 is the index number, so the tile that you're referencing, that you actually want displayed. In the case of 8x8, you can choose one of 2 sets of tiles, so either the first set of tiles or the second set of tiles, it looks like. And then For 8x16, you don't get a choice. It ignores that, and then the actual tile number, right, it's from 0 to 254. And then you've got your byte 2, which is, like I said, the palette. And then you have priority if it's in front of or behind the backgrounds. That's something we haven't really talked about at all. That's going to really depend on, you know, what the levels call for. And then this is the flipping bits of the sprites. So, and then the X, right, or X positions. All right, so let's go back to this and start actually handling how we're going to do this. So the first thing we need to do is determine how many sprites we actually need. Right, so based on, let me think about this. So what's the easiest way going to be to do that? If we have something like this here where it's 2 by 2, what is that? That's how many pixels in all? It's 64 times 4. So if we just divide by 64, is that going to give us the number of sprites? I guess it will, right? So because that's going to be, yeah, I mean that works. So we just divide the number of pixels by 64, and that should tell us how many sprites we need. So we need to load the sprite. Which thankfully we have a function to do that. And then we have the file name. So that gives us that, and then we say total sprites is equal to current sprite width times current sprite height divided by let's see, for 6, because 32 is 5 shifts. All right, so that gives us the total number of sprites, and we can validate this on a couple of examples. So based on that, then we're going to have to loop for however many sprites we need to output. And then once that's done, I keep trying to put that in quotes. I'm not sure why. We're going to jump to check end sprites because we're done with that. Yeah. So let's make sure my totally untested theory actually works here. I mean, I don't see why it wouldn't, but I have been known to make silly mistakes like this. So let's see. So this is which sprite? This is the blaster, which is 16 by 8. So that says that's 2 sprites. That looks okay. That's actually correct. The flyby should just be 1 sprite because it's just an 8 by 8. So that's good. The player is 4 sprites. That's correct too, because it is a 16 by 16. Okay, so it's good to know that my brain isn't completely leading me astray here with that calculation. So did that I did. Okay. So you can see it added the jumps here, which is good. So now the next thing we want to do is for each of these, we want to essentially copy this code, right? We want to load the Y position. So let me think about that. So we need to load the Y position, and we may potentially need to offset the Y position based on the arrangement of the sprites. So for the player, because it's 16 by 16, okay. So we're just going to do that based on Y and X, I guess. Let me think about that. Yeah, so what that would mean is we'd say, okay, we have our Y, we have our X, and every time we output a sprite, we're going to increment the X value by 8. And then once we are equal to the width, we will reset X and increment Y, and then if we've hit the width, the height, we're done. Right? I mean, that's a pretty straightforward process. So what we're saying is, okay, we've got our first sprite here, we're going to generate our next sprite here, we're going to generate our next sprite here. We hit this, okay, Y gets incremented and X goes back to 0. So we're just looping through, but we're also keeping track of how many sprites we're outputting because we need to output the proper number of sprites. Now, we should probably keep track of the total number of sprites that would be required to represent this, because, you know, the NES only has 64 sprites, and then there's also the limitation of the 8 sprites per scan line. I don't know that we want to get into testing that right now. Let's go with the sort of straightforward approach here. I do think I want to output, similar to what I did here, where I output a comment for which sprite we're working with. I want to have a comment that has the X and Y values at that point in time so that we can see what we're actually working on. So X and Y, and I forgot the file. Okay, so that's our comment, and then this is a pretty straightforward process here. We're just saying they all require tab and new line. We're just saying load A entities plus entity Y position X. So this is giving us the Y coordinate into the A register, and then we're going to store that into our sprite memory. So store A sprite mem Y. So that gives us that, and then we want to increase Y to the next byte in the sprite memory. Actually think we didn't need to do this. We can just do this instead because it's 4. All right, so now the next thing we need to do is the tile, which I don't know what the value is yet, so we will figure that out at some point. Then the next thing is the palette. So tile, let's do this. Y position, tile, palette, and mirror bits, right? We can even visually group those a little bit differently, and then X position. And this becomes this, and that is technically all it would need to render that. Oh, except that is, well, okay, so that actually works, but I want to have the x and y increment properly. So 8 if x is equal to current sprite dot width y plus plus x equals 0 if y equals current sprite dot height break, which it should technically do anyway, but oh, and I did y plus plus, but I meant y plus equals 8. So we've exported that. We go to Sublime Text. Okay. Cool. So we've got, for the blaster, we have 0080. That's fine. Again, the tile memory and the palette are sort of indeterminate at this moment because we haven't even dealt with how that's going to be calculated yet. But this is good. The comments are actually appropriate. And let me do this. I think I want this to be offset just so that it's in line a little bit better. I probably want to add another new line. I know it's not technically important, but I like to have some visual indications of what's going on in my code, just for my own sanity, to be able to see it a little bit more clearly. The things are grouped. Oh, except I did the new line in the wrong place because we have this that I forgot about. Come on. So we export that and go back to Sublime Text. Come on. Okay, cool. So those are now. Oh, I see. So I technically wanted both, is what you're telling me? Yeah. All right, so. So this will only do that unless we hit the end, and then we won't get a double new line. Right? Did I do that right? Yeah. Okay. Cool. So that's the groupings for everything. So I know this is going to break because we're not getting the tiles properly generated yet. And the problem here is that the tile offsets, so the tile offsets would be easy to calculate, except that right now in this, we're hard coding in the inclusion of the title screen. And we could change the title screen so that it comes after the assets that we've loaded in. Kind of hate to have to mess with that now, though. Title screen, ink. So that's just including that bin. Where is the compressed screen data? What did I call that? I thought I just, oh, okay, that's right. It's right. It's there. That's why it's got that label. All right. What I'm looking for is shooter char. which is this. So it's including I wonder if I could if you're able to do that. Like, are you able to just what I'm trying to think of is if it would be something that I could just do something like that. Is that the yeah, so you can't do that. I thought maybe the assembler would know that because those are constants, you just add them up and get the resulting value. Well, what we'll do is we'll cheat for now, because what I'd like to do is just get this working for tonight. So what we'll do for next week is we'll actually get this so that the title screen is part of this thing, and then we'll build backgrounds, and then the background will actually be treated the same as the sprite information is. So what I want to do is I want to shrink this char file. I don't want to include the shooter ship information or any of this stuff like that, because that'll come from the tool. And I need that one space there. So what I really want to do, is there a way to just like delete these? I mean, I know you can like blank them out, but what I just want to shrink this file. No, I don't think so. So if I set this tile to be something that's easily recognizable in the hex editor, maybe I can figure out how to eliminate that stuff. I just want to shrink this char file down to literally just the title screen content. And maybe there's an easier way than this. I don't really know YYCHR very well. But let's try this. So we should see, there should be, yeah, so this would be the tile that I created that had a bunch of that color. So I chose that color specifically because it meant that all the bits were going to be set, right? So if you go back to this for a second, if you remember, because we're dealing with 4 colors, and the way that the NES stores the data in these tiles, you're dealing with 2 sets of, or not 2 sets, you're dealing with 16 total bytes for the tile, 64 bits times 2. And the reason is because of the way that it splits up those bits to store the data. So if I make this the 4th palette color, then both sets of bits in the 2 8-byte arrays of pixels will be set to 1, which means that if I just look for this FF stream here, I know I've found the tile that I initialized to that 4th color. So now I can go in and I can, well, before I totally destroy this and potentially regret that, let me make a copy of this and delete those. Right, okay, so we've got that. That's super tiny now by comparison. Yeah, so that's just the 2K, and then, oops, not my get ignore. If we reload this and take a look at it, we should see just the title screen data like we want. And yes, we do, and that tile is gone, and that's cool. That's what I wanted, so that's good. Now, for the slightly scary part, we're going to take our draw entities, put it into the shooter folder here. Okay, that actually built. Now I know that there's going to be stuff that's not working. Like, for example, the sprites are going to be totally messed up because none of that's actually loaded in properly. The tiles are just hard coded to 0, sort of the palettes. So we'll have to fix that. But the good thing is that now we can kind of start with an offset in the asset tool just for the testing purposes of what we're doing here. And then, like I said, for next week, we'll actually bring the title screen into the tool so that we can account for it in our calculation of the tile offsets in the char ROM. So let's see how awful this looks now. Okay, so that's at least good. The title screen is still what you would expect. It's still bringing in the guy from our previous tests, because in the include file that we're using to bring in the char data, we're still bringing him in here. So what we want to do, we want to change all of that. So I want to get rid of this, and then what I want to do is I want to say include, I'm actually going to include a different file, entity char.inc, and then that's the file that we're going to generate in the asset tool, where we actually export the sprite image data out to files, and we'll generate that include file that will append that to this. This way, at least the title screen will be correct. And then, like I said, we have to just fake an offset here, knowing that the title screen is sort of predefined. And yeah, cool. All right, so hey, Kevin. Yeah, I that was what I was going for with the hex editor. I was just kind of hoping that that would actually work. All right, so let's see here. So we've got this. I want to just export for each of these. I want to export the sprite char data. How do I thought, how are we doing this in, is that in current image? How are we composing this? I don't remember. List item is image, is sprite, load sprite, and then it draws. Okay. So I am going to convert this into a function. Call it sprite to image, current sprite, and then we don't have to, okay. Sprite to image, sprite, and we'll just call this, yep. Image is going to be this. So basically we're allocating a new bitmap, we're calculating how big it is, and then this is the same thing as we were doing before, where we're iterating through the sprite where it has the image data indexed by the palette that's stored in the sprite, and then we're converting that over to RGB from the NES palette that we have defined in the asset tool. So that gives us our sprite back, and then the good thing about this is we can reuse it here, right? So what we need to do is we need to say tiger pointer image sprite to image, current sprite. Let's call this export image just so it doesn't conflict with the other one. And then we want to export image. No. Yeah. Yeah. Export image, and then replace file extension. Okay, let's do that. Oh, actually, if we have the file name, do we need that for anything else? No, I don't think so. So we can take the file name, temp, and dot char, and max count is 100. So we're going to just add the extension to the file name that we were using here. So now we've exported the image. So we have that. That's cool. That's what we're going to need for. So we're going to have to generate a separate list again of the char files that we're exporting. That's easy enough to do after we're done with all of this. And now we can calculate the tile, right? So based on this total sprite count, we can increment a tile counter. Well, actually, we just could use a tile counter. We don't even need to use the total sprites to do this. But all right, so because for each of these things that we're going to be drawing, the tile will increase. At least at this point, because we're not sharing anything. That'll change if we do any sort of tile sharing, where between the tile sets we've kind of combined and mixed and matched things, but I don't want to get there yet. One simple step at a time. Current tile 0. So let's replace this with our current tile. And then we increment it after we've written it out. And that will be fine. So that's good. We don't know anything about the palettes yet, so we're going to keep the palette and the mirror bit where it is. Oh, the current tile has to be shifted by a bit because of this crazy thing where the first bit, wait a minute, where is it? This first bit is actually the bank, if we're using 8x8, which we are. Eventually we may change that, but so let's do this. So shift it by 1 and then current tile. Okay, cool. So we got that. And that seems like we're at where we need to be there. The only thing, like I was saying, is we want to offset this to accommodate for the title screen that's in the char ROM. So we'll get to that in a second. So that looks good. We need to export now the list of the actual char files, which we're generating here because we're loading the sprites. So I mean, the order doesn't really matter. I'm just going to be lazy about doing this because I want to kind of steal a boilerplate that I've been using here. So I want to call this, I'll just call it char data. Char data, and we'll call this, what did I say we would call it in here? Entity char. No, except I have, that's not Nintendo-like at all. It's got to be missing that A. Dot inc. And if char data. Let's see, now I'm not being consistent. Okay. So if we've got our char data, let's close the file when we're done with it. The first thing we need to do, first thing we need to do is we need to get the name of the file that we're going to be putting into that list. And this is the same old stuff we've been doing, where we get the file for the list. Okay, so and then we're just going to do a bunch of ink bins here. Probably make that a constant. I'll fix that in a second. All right, so ink bin, name of the file, new line, temp, and this doesn't have an extension, so we'll add the .chr because it's going to have that when we write it out. And that's it, except I guess I don't need that, right? Well, I know that's not there. Okay, yeah, so you don't need a tab for that. All right, well, that was easy. That was, yeah. So we'll call this include file header. Okay, cool. So we got that. All right, so we're generating our entities. We're generating our entity character data, our char data. We're exporting our draw routine with the corresponding sprite tiles. And that should be enough to get us back in business here. Now, the only thing is I have no idea how many tiles are in that title screen. Let's where are we at here? What is this? 58. Okay, so 0, so 58. So we want to start at 59. Again, this is just a hack to get this working because we don't have the background data actually as part of this. What's the matter with it? Oh, come on. Temp 100. 8. Sprite to image must return a value. Well, sure it must. That's not. What's the point of making an image if it's not going to get returned to somebody to use it? All right. So that's all looking good still. So let's export exception thrown. Que paso? What happened here? Width, height, indexed. Read access violation. Oh, indexed is empty. Right. Right. Okay. So that was just because the way that the tool is working, it's not looking at the raw image to generate the char data. It's actually looking at this new field that we added to the Tiger image called indexed, which is just the raw data that we're getting from the file, or the raw data that we're generating. The reason we did that was because there is a we have a need to draw the sprites scaled, but the index data that we are interested in is going to be just, you know, the raw data. So we don't need that to be scaled. We want that to be actually one-to-one for use later. So let's see. So what is this? This is a, well, before we do anything, we just say sprite image I. Okay, so that's the raw data. We need to actually allocate that because this doesn't normally get allocated by Tiger because it has no idea what this is because I just created it myself. So unsigned character pointer, size of unsigned character times total bytes. All right, so we've got our memory. Okay, so that should stop the exception from getting thrown now. And it did. That's good. So now we should have a bunch of additional files. So we've got the blaster char file, we've got our draw entities inc, we've got our, okay, so that's all looking good. So let's see how that actually looks now that we've exported it. So here's our drawing code that got generated automatically. That looks like we would expect. That doesn't look like what we'd expect. I don't know why. Why is that 118? 118. Current tile is 59. Doesn't increment the current tile until we are here. What? Why isn't that just 59? Current tile shift. Oh, right, because we have to shift it by 1. So 118 in binary, right shift by 1 is 59 decimal. Okay, cool. Right, I totally forgot about that. Okay, cool. So that looks to be what you would expect. The entities include file is still okay. The entities character file is good. These are all of the different, oh, why is it doing it twice? That is not good. Is sprite. Where is this? Current item count. Oh, because the sprite. You know, I go to all the trouble of copying my own code and I still screw it up. Okay. Name. Okay. That should fix that. So let's run that and export and close and yeah, there we go. Just one time. That's all we needed. YYCHR. Let's see if you can confirm that all of this stuff actually looks reasonable. Yes. Okay, cool. So that's our blaster ship. And that's the flyby. And that's the player. Awesome. Okay, so that's good. So at this point, we take, and you know, for all of this, we'll probably, well, part of the reason that it's in a different folder is because we're working on the tool, right? So all of the stuff is in the NES Asset Tool home folder. The idea would be that you'd have the executable for NES Asset Tool in your project folder, and you just hit export right there, and it dumps everything into that home folder that you're looking at. So that's not something you moving the files over generally are not. It's not something you have to deal with too much. So okay, so we've replaced that stuff. I know this is going to fail to build because bullet is not defined in the entities list. So bullet is equal to 4. And again, that's because the asset for the bullet is not something that is actually in the project folder. I'll bring that over along with the title screen so that I don't have to keep manually modifying that file. So here, come on. Bullet equals 4. So we confirmed before that just changing to these entity types worked. This will be interesting to see if the drawing code actually works, because this will be the first time we're trying it out. I mean, there's no reason it shouldn't, because it's essentially the same thing I was doing before, where I was copying the sprite mem, or copying the entity data into the sprite mem. But we'll see. We'll see. All right, so good news is it assembled. We still have a title screen, so that's exciting. Okay, that's really cool. So we've got our stuff, right? We've got our blaster, we've got our flyby, and we've got our ship. I don't think the ship is going to actually draw, but we'll see. Yeah, I didn't think so. All right, so that's okay. Let's see. Let's take a look at our memory here and see what the... Well, the memory isn't going to be what we want to look at. We want to look at our code that's actually doing the drawing. So let's pause that for a second so it doesn't distract me with scrolling. All right. So what I want to find right after the v blank, basically. And I've said it before in other streams, I think we're going to have to switch to Nintaco, because I do like that it has the ability to view the OAM, the sprites, and while I can see different parts of the memory here in FCEUX, I don't think there's a way to see the sprites in here, which is definitely less desirable. Anyway, so let's go find, so that's our controller code because we're doing our rotates. Let's see if we can find let's do the trick that somebody else recommended. Let's do this. Let's load A. Well, it doesn't actually matter what we store there. Let's store A into memory location 799. Let's rebuild that, and let's reload the ROM, and then we'll set a breakpoint on write to that location, because that actually worked really nicely. That was much better than my no-op idea where I was looking through the code visually. So let's go to the debugger, let's go to the hex editor, let's go to 799. Oh, 799, that's not what I wanted. Getting tired, 7FE, that's what I wanted. Seven FF, 7FE. Let's set a breakpoint, add write breakpoint there, and then bam. All right, awesome. Cool. So now we can actually look at our code here and see what I'm screwing up. So the first thing I want to look at is I want to look at my OAM data and see. Oh, wait a minute. Is it because I'm, so this is tile 59, but I believe the problem is that I am looking at, for tile 59 here versus over here, which is where my sprite stuff was previously. And let's take a look at this, because I remember, let's see, bank 0 or bank 100 of tiles. Now, I was under the impression that this was bank 00, but that may not be true. Oh, wait a minute. I confused myself because this is actually for the 8x16, not the 8x8. So this is the tile number. Okay. Well, that would probably explain it. So what I was doing is I was shifting everything by 1 bit, but I didn't need to because that actually applies to 8x16 and not 8x8. So let's fix this. Okay, so let's re-export all of that. Good, and let's copy it over again. And then we have to manually add the bullet to the list, but simple enough to do. Okay, so now let's reload that. Debugger. Uh-oh. Did I do the wrong sequence to load the ROM and unload the ROM? What's going on? Run. What's going on? Okay, let's why does it keep rebuilding it? That was weird. Okay. So let's go back to the PBU viewer. Let's look at the debugger. I don't know if that break is still there. It's not. Okay. So let me add that breakpoint back. I think now what the problem is, I'm actually, okay, wait a minute. Yeah, so the problem now is that the the other part of what it said here. So based on bit 3 of PPU control, so I have a feeling I'm probably setting that to be 1. So let's take a look at that. So that's set to 0 there. That's set to 0 there. Set to 0 there. Well, so much for that idea. Oh, wait. It is set to 1. No, but that's bit 4. That's not bit 3. 0. Oh, wait. But that would be bit 3. So if I change that to 0. Alright, so that's better. I'm getting something. I'm not sure what that is, but that's, at least it's not just completely black, and it moves around. And you kind of get... Alright, cool. So it's like a weird version of my sprites. So let's see. I'm not sure what that actually is, because it should be loading tile 59 into that location. So if we go to 7FE again and set the breakpoint, 7FF, 7FE, right breakpoint. There we go. And let's see. So we're going to load A with the value of 3, and we're going to compare it. And that would be, I think, the player based on, yeah, so that's going to be the player sprite based on the just the sheer number of increments that it's doing here. So let's see. So it's going to store load A. Let me look at this here. Load A, and then store it into sprite mem, and then increments. So then this is, oh, well, that was dumb. So I'm loading the tile, but using an offset of X, which makes absolutely no sense. Okay. Again, copy paste. Just screwing me up. All right. As a tool, copy, paste, replace. Let's go into, that looks better, right? Because that should only be just storing the tile value. Although that 59, damn it, that needs to be hex, and I need to, okay. And you gotta do that, you gotta give it the right prefix, okay. All these little things, right? That's always what it is. If we come back to the draw, yeah, there we go. That looks more like you'd expect. And then we got to add bullet back because it's not there. And we build, and it actually built. And I think I'm hitting the wrong. Is it Shift F1? NES. I think I'm pausing it. Normal speed. Normal speed. Why does it keep? Do you have to just undo the pause? Oh, okay. Run. Okay. Sorry, that was just silly. So let's turn that off. Still getting the wrong thing. So we're not getting the ship like we should. Let's turn that back on. Step over. Compare it. Okay, so it jumps for the player. And we're going to step over that, and we're going to increase. So then it's going to load 3E, which if we go to 3E, 3D, 3E, right? Into sprite mem, and 3E is what? $62 in decimal. So let's take a look here for the player, ship, tile. Well, it's not right at all. So did I miscalculate? I guess I must have miscalculated. Oh, it's 59 hex? Oh, come on, man. 89 decimal. To know why the make file is, I guess it's because it's not actually doing anything for these. Well, that's all right. So let's keep hitting the wrong key sequence. Okay, so that's running. Disable that and just see what it does. So the palette colors are expected based on the palettes that are currently loaded in, but what? Is that the ship? Can't tell. Not exactly. What is that? That looks like something else. Not sure what that is. That's weird. All right, so step over. What is it loading? It's loading in 5C for the tile. And 5C for the ship would be that. So is it just loading in garbage data from here? No. So 5C is technically right. This is where having the OAM viewer would be potentially useful. So let's take a look at the memory for these sprites. So let's go into the hex editor, and the sprite memory is in 200 here. So what is it actually writing to? It's writing to that. So this is the next time around. So step over. Is it offsetting it incorrectly? is it doing it over here versus... Or is that not even related? That might not even be related. So x is 0, y is 0. Okay, yeah, so it's not even related. That's just, it just happens to be updating that. So did I just incorrectly change my my bit here? No, okay, so that was right. I was looking in, still looking in the wrong bank here. Let me make sure that. Let's take a look at the reference here, because I'm sprite pattern table address. So it's either going to just be 0 or 1. So I want it to be 0. And that's fine. But it's still giving me the wrong, like, I don't know what that is. It's obviously part of something. Oh, wait a minute. Is it because the color... Is it because the colors are wrong? Maybe that is right. Maybe that is right. And... yeah, so what I think is happening is it's actually correct in terms of... That's interesting. Okay, so the problem is that the background color isn't the transparent color. So I'll have to fix that. And that is the right first sprite, but it doesn't seem to be picking up the additional sprites. Why? Let's see. So where does it increment the x? So after it's done, it does that. Oh, right. So it increments the x here, and then it jumps out when it's done. It's odd that it's not draw player sprite. It's odd that it's not picking up any of the rest of... Okay, so like, see that flyby, that actually works. The bullets, you can't see anything because the bullets aren't there. Why am I not getting anything for sprites larger than one sprite at a time? You have the Y position, you have the X position. What was the original code? What did the original code look like? So for the player sprite, this is why I saved this, because I knew that something was going to be goofy and then I wasn't going to be able to figure it out. So we have the Y position, X, we store it, sprite mem. Oh, of course. That's why, okay. Yes, okay. That was why, that was the whole point of calculating the Y and the X value that we're putting in the comment here, because we actually have to change the X and the Y position accordingly with this in order to actually represent the sprite or the entity with multiple sprites. Right now, all the sprites are stacked on one another, which is probably why it looks a little weird, because whatever odd transparency is going on is causing it to look a little bit different than what we expected. So what we need to do is in our code that we're generating for drawing the sprite, we need to actually, okay, so we need to actually change the value of the X and the Y as we go. So, interesting. Okay. So for the y, if the y is 0, then we don't have to do anything. Otherwise, we have to do a clear carry and add for the value, right? So totally forgot about this part. Except I'm in the wrong spot. Okay, so if y is greater than 0, rather, we want to clear our carry, and then we want to add with carry for our hex value of y, right? So whatever that value is, we're going to add to it, and then we're going to store it, and then the same thing goes for x. I think that'll fix it. So let's export that. We copy these files again. Come on. Replace. Excellent. And then let's take a look at this. So player sprite, this guy. So for y, why didn't it do it? So it did it for this here. I know I just did something stupid. I don't even have to. Yeah, dummy. I changed the value being printed out as x, but I didn't actually check x. Okay. Export. And there we go. So we are incrementing by 8 here, then we're incrementing by 8 there, then we're incrementing by 8 in both places. That is good. Bullet equals 4, build, FCEUX will reload, please. No, not save state. Hey, there's our ship. And like I said, the bullets are not loading and the transparencies are broken, but that was generated all. So yeah, so okay, so that's cool. So it's generating our entity list, it's generating our sprite drawing code based on the entities that we're including. Palettes obviously aren't working. The order of the colors isn't working, and we're gonna have to mess with that. So I think what we want to do is when you click on the sprite, you probably want to just say, actually, you need to make this the transparent color, and it reorders the colors in this and also in the palette so that you get the transparent color here for the sprite, and then that'll fix that problem. Even if the palette colors are wrong, we have to deal with exporting the palettes, and then the title screen and the bullet need to be included in this entity list, but that's pretty cool. That's working. That's working. So I'll consider that a win. And it is 11 o'clock, so I'm going to wrap it up on this Thursday. And anybody watching have any questions or anything they want to ask about? I'm going to do a couple things here. I want to commit this change. I'm going to start a repo for the asset tool also, but what I really want to do is I also want to, I don't know that I need to include these because these are all automatically generated. I don't really care about those, but I do want to stage that. I want to stage that. Any of these? No. No, I'm good with these being not there. So got external asset tool generating content for game. Commit that change. So that's good. And yeah, that's where we are at this point. So for Monday, for next week, we'll get the asset tool allowing you to reassign the color that's the transparent color and reorganize all of that. It will also, we'll have to start tackling the backgrounds. So loading the, for example, the map as a background in that, for now, just that really simplistic run length encoded format that we were using. And then start on levels, I guess, because basically at this point we're in a situation where the content that we're going to be generating and loading in the game is going to be specific to, we could also export the bounding boxes too, because we're not doing that yet. We'll have to do that right now. The bounding box checks are, let's see, there's just this basic collision detection based on the type of entity it is. We'll have to fix that, and that might be interesting, because that might also be a case where we generate code based on the bounding box rather than exporting the bounding box data. I don't know, I'm not sure. We'll see. I mean, the problem with that is, then you have more code and you got to balance that in terms of what you can fit on the cart versus the amount of data you want to use in the cycles necessary to check the bounding box. I don't know. We'll figure that out next week. But anyway, what I was saying was that for the levels, you have, that's where you're going to start dealing with things like, okay, if I want to have the blaster and the flyby and a couple other things and the player all on one level, we're going to have to look at, okay, what's going to be on the screen at any given time? Are we going to be able to support the number of palettes it's going to try and use? Do we want to do something where now we maybe change the colors used by the flyby and the blaster so that they use more common colors in order to reduce the number of palettes? For the player sprite, we want to talk about how to duplicate these tiles. Same thing with the blaster sprite, where we're going to mirror this side on here. I don't know if that's going to be an automatic process. Probably not to start out with. Probably we'll be able to do something like, you select the tile and then, or maybe you select the tile and say, horizontally mirror, and then you can modify which tile it's using. I'm not sure. I want to also implement the ability to drag and move this bounding box, which you currently can't do. It probably doesn't need to show the bounding box every time. So there's a lot of stuff to do, but like I said, what's cool is that we actually have this working pretty well. Again, we may find, just like what I was saying with the bounding boxes, that generating code to draw the sprites maybe isn't the most efficient thing to do or practical in terms of cart size, or if we're going to run into problems where when we have these jumps, they're going to be too far because we're going to have so many different entities here. And there are ways around that, but maybe that's where we start to reevaluate how we're doing that. But for now, we've got it working the way I wanted to. And only time will tell if we have to change anything. So if nobody has any questions, as always, if you want to reach me, you can find me on Twitter at Clervis. You can always comment on the YouTube recordings of this afterwards to try to get back to you guys pretty quickly. And then I'm on Nintendo Age as well on the Discord, and a bunch of great people there. So definitely check that out. And I will see you Monday. Have a great weekend. Take care.